Hello everyone, welcome back to another episode of my tutorial series. In this episode we're going to be working on creating a asteroid field that will procedurally generate asteroids in a radius. So the first thing we're going to want to do is add the plugin for destructible meshes. And if we go to built-in here and we say destruction, you want to enable apex destruction. Dismiss all these and restart. Awesome. So now that the project has restarted, one thing to note is that I have included the starter content for the SM rock mesh and also the map preview. So this is just to I want to use multiple meshes, so this is just to demo what the system would look like with multiple meshes. Generally you'd probably want to use multiple rock meshes and whatnot. So the first thing we're going to do now is create a destructible mesh for each of these, and you can see what that looks like here by clicking fracture and then testing that out. And also you want to do it for the other meshes that you're going to be using. Alright, sorry for the cut, but that took a little bit longer than expected. Now that it's all done, we're going to save, close this out, and you'll see that we have two new destructible meshes here. So next what we're going to do is we're going to go into our blueprints folder. We're going to create a new folder called world objects. And inside of it, we're going to create a new blueprint class. And this one is going to be of type actor, and we're just going to call it BP underscore world asteroids. And now what we need are just a few variables here. So the first thing is going to be of type actor, and then the next one is going to be of type static mesh. Oh, and actually I take that back. This instead of actor, it's also going to be of type static mesh. So we're just going to create a new one here, and then we're going to add a few integers, 3 total, and we'll start naming these off. So the actually we're going to have to change these. So if you come over here and you change it to a map, you can set a second variable type. And we're going to, for the first one, we're going to do a vector 2D. And the second one, we're going to do a destructible mesh. Destructible mesh. Perfect. And if we compile this and save, and we see here, yes. So next what we're going to want to do is we're going to, for each destructible mesh, we're going to want to find the static mesh that is associated with it. So this one's going to be called map preview mesh, and the second one is going to be called SM rock. And then for the first map, we're going to set some scales here. So following the exact same layout as the other one. You just want to make sure that these are lined up properly, so when we reference them as variables, we can just use the same index. So I'm going to click the little find right here, and then we can come over here and just push the arrow, and that'll drop it in. And so this is going to be our scale, but I'm going to add the other one here really quickly. Awesome. Alright. So for the scale, we'll have it at 1 and then 2, and then for the rock, we'll have it at 0.5 all the way up to 3.5. Compile, save, and then we'll start naming all these. So this is going to be asteroid meshes to scale. And the second one is going to be called static mesh to destructible map. You can name them really whatever you want, but these are, I like to get really descriptive with them. And then the next, our first integer is going to be called unique asteroids per octant. The next one is going to be called minimum radius, and the second one is going to be called maximum radius. So before we get into setting the default values for these, it's best to describe what exactly we're making, and I think the best way to describe it is with an arrow. So essentially what we're going to be doing is, and actually let's add some planes. You don't have to copy this, I just wanted to demo what exactly we're making here. So if I rotate these, and I rotate these, you'll see that we have 8 sections. And what we're going to be doing is, there's a system in Unreal Engine called it's called Hierarchical Instant Static Mesh Component and Instant Static Mesh Component. The difference between these two components is the Hierarchical Instant Static Mesh Component uses something called LODs, L-O-D. And what that does is it will essentially, for mesh, say, you'll see here that there's LOD auto. This one doesn't have any LODs, you'll see there's only one LOD, but it's a way for essentially Unreal Engine to, as you get further away from an object, it'll de-res and make it like a lower poly model, so it's a little more optimized. So we're going to be piggybacking off of that, and also what instant static mesh components do is when you place an object in the world, so for each one of these, you'll see that these two are the same mesh, they're just flipped, right? So if I were to have a bunch of these in the world, your GPU would spend one little cycle of its rendering time rendering each object. So what an instant static mesh component does is it essentially groups all the same mesh objects together, and it'll spend one GPU call rendering these objects. So it's a way to optimize, but there can be a downside. Say for example, the reason why we are splitting the spawner into these octants is because, say I'm looking in this direction, we only need to render what's over here. And say I'm looking over here, we only need to render what's in this octant. But for example, when I'm looking in towards it, it would be rendering every single octant because one of each would be inside of the frame. So it's just some way to slightly optimize. Obviously, if you want to optimize way further, what you could do is you could split it even further and stuff like that, but we'll get into how to make this, and then if you want we can go in optimizing later. And then essentially what the arrows for is, so we're all going to be starting from the center position, and we're going to just find in each octant we're going to find a random vector to look out from, and then we're just going to multiply that by a distance. So that will create our spawning locations for that octant. Alright, so now we're going to create a couple functions here. We're going to call create asteroids, and another one called create asteroid octant. And then we're also going to be utilizing the construction script here. So from the construction script, we're just going to call create asteroids. And then in the create asteroids, what we're going to do is we're going to have a for loop, just a regular for loop here. And so since it's an octant, we're going to start at 0 and we're going to go up to 7. And then for the next thing we're going to do is we're going to get our map of asteroid meshes to scale. We're going to find the keys, and the keys are these first objects right here, not the vectors. You'll see it outputs an array of static meshes, and on this we're going to do for each loop. Next, what we're going to do is we're going to call add hierarchical instant static mesh component, and the transform, we're just going to split it so it spawns at the default scene root 0. We're going to attach to component, attach component to component, and this one's going to be taking in the default scene root. For everything we want to keep relative down here. We can weld simulated bodies, that's fine. And then what we want to do is we want to drag off of our new hierarchical static mesh component again, and we want to set static mesh. And for the mesh, we're going to take our for each loop, and we're just going to plug that in. And then we can drag it up so it's a little cleaner. And then from here, what we want to do is we want to say find. And this is going to take the asteroid meshes to scale. And then we're going to call create asteroid octant. But before we do that, we're going to add a few variables here. So it's going to take, the first component is going to be a hierarchical instant static mesh component again. And we'll just call this the abbreviated HISMC. And then we're going to take 3 booleans. And this one's going to be called X positive, and then Y positive and Z positive. And then lastly, we're going to take that vector 2D called scale. Awesome. So now if we go back into create asteroid octant, or create asteroid, sorry, you'll see that these variables are added now. And what we can do is we can just drag this in and place it here. And for the scale, we can just drag that. And then for these, we want to do a select. And this is going to take that array index from our for loop. Not our for each loop. So I'm going to add, so we're going to have 7 iterations, so I'm going to add 7 options here from 8 options from 0 to 7. And I'm going to create 3 of these. And essentially what we're going to be doing is just creating like a round robin type of deal here, where we essentially get every single one to be either X positive or Y positive or Z positive within the given times. So I've already worked all this out, but you can just copy along here. So it's these 4, 0. This is kind of very similar to binary addition. So then 2 here and skip 2, and then 2 again, and then this one's going to be every other one. Awesome. So now we can actually build out this create asteroid octant. And what we want to do here is we're going to have another for loop. And this is going to take the last index of unique asteroids per octant. For this, I'm going to set it to 100. So what this is going to do is for every mesh, every single mesh, there's going to be, since I just set it to 100, there's going to be 100 of that mesh in each octant. So a total of 800 of each mesh and a total of 1600 meshes if we are using 2 different meshes, and then 2400 if we're using 3, and etc. So next what we want to do is we want to take our X positive, and we're going to do a little select here, and then we're going to get integer times float, and we're going to plug the return value into this, and we're going to get a random float, and then we're going to do a -1 and 1. And then what we can do is we can just copy this 3 times, and it's going to be 1 for each. So essentially what this is doing is it's going to get a random 0 between 1 and 0 and 1, and if z is positive is true, then it's going to be times by 1, but if it's false, that means z positive is negative, and we're going to multiply by -1. And then from here we're going to make a vector. and we're going to clamp. And we're just going to set the min-max to 1. And then we're going to times this by an integer. And we're going to take the minimum radius and maximum radius. And we're going to find a random integer in range. And we'll do here select int. And then what we're going to do is take our scale and we're going to break it. And then we can do random float in range from stream. And I'm planning on making another shorter video on just true random number generators in Unreal Engine, but this is how you would do it. So we're going to do make random stream, and then we're going to get now. You just type now. You can split this, and essentially what you want to do is you just want to randomly multiply and add some of these. So we're going to multiply the milliseconds by an integer, and this will be, we'll do like minutes times the milliseconds times the seconds. And if you want, you can like add month, add day, add hour, whatever you want. And then from here we're going to make a vector, and this is going to go into all three since we want our scale to be uniform. And then for float, we're going to do another random float. So remember, this is 0 to 1, and then we're going to times this by float, which is going to be 360. And then from here we're going to make a rotator, and this is also going to plug into all three, so we'll get a random rotation. For all these, random integer and range, random float, you can use the random float in range, and it'll be much more random, much more truly random. But for the sake of time, we'll just quickly go over this for the scale. And then lastly, we want the, let's see, what is this doing? So we're going to take our minimum and maximum radius again. We're going to flip them around, and then we're going to subtract the minimum from the maximum, and then we're going to add back in the minimum. This seems a little redundant. Actually, I'm just going to do, that would just give us the maximum. Oh, this is to make sure more spawn around the edges. Got it. And then what we're going to do is we're going to multiply our clamped vector by this integer. And what this clamp will do is it'll make sure that it's a full size vector. So say like these all reach like 0.1, 0.0001, it'll essentially scale that up. So it's a full value of 1. So you don't get stuff that's like huddled in the center here, and that'll spread out a little more, a little better. And then lastly, we're going to take our hierarchical instance static mesh and we're going to add instance. And for instance transform, we're just going to take the 3 little things we got here. Maybe stretch it out a little so it's a little cleaner. And looks like the scale is really big and also the radius. So we're going to add minimum radius is going to be 1,000 and the maximum radius is going to be 30,000. Awesome. And then if you just want to demo what an octant looks like, we can set our for loop to 6 for the time being, and you should see that an entire quadrant of these is missing, and that's how you know that it's working. So you'll see from the center, if we look at the center where they're all huddled up, you can see a very clear-cut line this way and also a very clear-cut line this way, and then also if we look from here, it's not as clear-cut. That's due to the random nature of it, but generally you won't find a single thing in this section. And if we put that back to 7, so now we can play with some of the values here. And we'll say, so these guys are looking a little big, so I'll set this to 0.5 and 1. And you'll see they get much smaller. And then if we do static mesh to destructible map, that looks fine. And then maybe the scale of these is honestly it's fine. It's maybe a little too big actually. So we'll do 0.2 and maybe 2. Yeah, that looks good. And you'll see some really tiny ones down here. Awesome. So now let's get into actually making them destructible. So we have our project with our shooter. So we want to make it so the shots fire a interface message. So what we're going to do is we're going to come to our base projectile. We're going to double check what's going on here. So we are sending the applied damage before we destroy actor. So in between this, we can add a little interface message. So we'll come, it doesn't look like it's using any previous interfaces. We're using a sphere trace, okay. Interface right here. So here we're going to make a new blueprint interface. This one's going to be called BPI hit Asteroid. And then we'll just call it hit Asteroid. And then we're going to give it 2 parameters. One's going to be called component. It's an actor component. And this is going to be called hit component. And then we're going to create a new integer. This one's going to be called index. So now on the base projectile here, between our damage and the thing, from our hit actor we can do hit asteroid message, and then hit component we can just drag in hit component, and then index we can drag in hit item. And then what we want to do is make a new actor here. So we'll go back to Blueprints World Objects and we'll create a new actor, a new blueprint actor. This one's going to be called BP Destructible. Asteroid. And it's going to take a Destructible component, and what we're going to do is we're going to add a variable called Destructible Mesh. And then two vector parameters here. One's going to be called forward vector, and the second one called hit location. And then on our construction script here, we want to take our Destructible here and we want to say set Destructible Mesh. This will take in the Destructible Mesh. And we want to also make sure that we click the eye next to all these, and we also enable expose on spawn here. So that way when we create this, when we spawn this actor, we have these variables exposed, and we can change them at will. So back in the event graph here, we can delete these two functions. We're not going to need them. We're going to take our Destructible component here. We're going to apply damage. Damage amount we can just set to 1. The hit location is going to take the hit location. The impulse direction is going to take the forward vector, and the impulse strength we'll just set to some arbitrary number. We'll say 50,000. And then if you want, you can like add like a play sound at location here. And then we're gonna have a little delay. We'll do like 4 seconds, and then this is gonna be the delay before we destroy the actor and we clean it up. You don't have to destroy the actor if you want, but as more and more grow, it's going to become a little less performant. Especially since all of these simulate physics and whatnot, so. And then next what we're going to do is actually create this. So in our world asteroids, we're going to implement this interface. So hit asteroid. And we're going to say event hit asteroid message, no, hit asteroid, call function. Oh, we have to come here to interfaces and implement function. There it is. And actually, just for these two things, what we can add here is we can say we'll add a vector called forward vector. And then another one called hit location. And we'll just pass these along to the Destructible. And in our projectile, we just want to make sure we take these. So the hit location is impact point, and then we can do the impact normal for forward vector. You might want to multiply that by -1. And then, so we're going to cast to hierarchical instance static mesh component. We can convert this to a pure cast. And then we'll say get instance transform. And the only reason we can do a pure cast here, actually, you might want to do a regular impure cast and hook it up like that. But I think it's fine since the only components here are the asteroids. If we were to add more components here, there's a chance that this actor getting this message would not be hit on an instance static mesh component. And then for index, we're just going to plug in instance index, and we can clean this up a little. good way to route that. Awesome. And then we're going to have a branch here, and we're gonna, off of this, we're gonna say static get static mesh, and then we're gonna get our static mesh destructible map. We're gonna find the mesh that it corresponds to the hit mesh, and if this was successful, then what we can do is just plug that into the branch, and we can spawn actor from class, and this one's going to be the destructible asteroid here. So the transform is just going to take the mesh's transform. The destructible mesh is going to be from the find, the forward vector is going to come from the forward vector, and the hit location is just the hit location. Just plug everything up. Then what we want to do is we want to remove the instance. So taking our hierarchical instance static mesh component, we're going to remove instance, and the instance index is going to be the hit index. So now if we take our asteroid field, move it up a little bit, you'll see that it's like randomly generating every single time I drag it around, and we shoot one of these. Oh, looks like the collisions aren't set up properly. So what we're going to do here is on our world asteroids, we're going to check our collision profile name. And we're just going to print block all dynamic. So we can remove that print again. And we want to make sure our trace is looking for block all dynamic, world dynamic. That is set up properly. Let's do a draw debug type for duration. Yeah, it doesn't look like it's hitting. That one worked. Now let's see why it's not spawning. So the destructible asteroid, it looks like the mesh has some problems. So we'll double check on that. Ah, yes. So this one is block all. We'll change this one to also block all dynamic. And collision complexity, use complex collision as simple. Let's see. There you go. Now that should work. And then we need to get rid of the traces. So remove that, and then we'll see here why we're not making asteroids. Always spawn, ignore collision. Alright, so I found the problem, and we just need to make sure that this world space object is checked right here. And that will give us the world coordinates rather than the local coordinates it was using. And then, so if we go and test this now, you'll see that it breaks, it fractures on the ground, and it splits apart. So if we go back into our world asteroids and we see our destructible asteroid, and you'll see physics is set. You want to do gravity, you want to disable gravity. If it's like an asteroid field in space, if you do want gravity, that's fine. And you'll see it breaks apart just slightly. And then what else we can do, we can create our, lower the impulse strength, we'll set it back up to 50,000. And now when we break an asteroid, it should really fracture apart. Awesome. Thanks for watching. I hope you have a great day. Please like and subscribe my videos, and if you have a request for a tutorial, feel free to join my Discord and ask me, or just post it in the comments. I really appreciate you watching, and I hope you have a great day. Take care.